Do you remember the three key or fundamental theories of machine learning? They are probability theory, decision theory, and information theory. So you can review it because now we are going to start talking about probability theory. Probability theory is the same probability theory you know from high school, where you have a box containing maybe blue balls and red balls. What is the probability that a ball taken at random will be a blue ball? So that is basically how probability works. In machine learning, it is no different. It's also the same thing. It's still simple, only that we have to now learn how to use notations to represent probabilities. So in the website, in our demo for today, we have a box containing apples and oranges, but I actually would like to demonstrate by myself using some of these things I got. So I'll have to demonstrate it so that it is a bit interesting using this. And also I'd like to remind you to subscribe if you've not subscribed to my channel. So let's get started. After this illustration, then we go to the website to now follow the lessons. And also I take out my keyboard because I'm going to actually be writing on the screen. So let's assume that we have pieces of papers of different colors. We have the pink one, we have 1, 2, 3 pink papers, and we have 3 green ones, 1, 2, and 3. So let me also add maybe a blue one so that it will have 3 items there. So I'm adding 3 blue pieces at this point so that we have pink, blue, and pink, blue, and green. Okay, so let's see. So in this way, you find out that probability becomes really very easy and interesting to work with. All right. So, okay, so let's put this away. So the question now is we have, let me shift this. I hope you can see them. So we have the green ones. Maybe I'll shift this as well. We have the 3 pink ones, the blue ones, and the green ones, blue, pink, and green. Okay, so I'm going to mix them up and I'm going to select a paper at random from all of this, right? All right, so the first thing I'm going to ask myself is, if I select a paper at random from these pieces of papers here of different colors, what is the probability that the paper I selected will be a blue one? So let's now start writing a few things. The first thing you want to ask yourself is, how many options are there? And how many options are there? We have 9 items. So let me take a pen and I'm going to write. So let's start with writing total. 9, okay? So the probability that I select a blue item or a blue paper from here is going to be written as, let me use a different blue color so that it becomes clear. So probability that I select a blue item is going to be written as PB. Let's call it PB. And the probability that I select a green one, okay, yeah, a green one is there, PG. And the probability that I select a pink one will be written as, I can't find pink, so let's use this to represent PP, okay? So what are these probabilities? The question now is, probability that I select a blue ball, a blue paper is going to be actually the number of blue items divided by the total. So it's going to give us 3 over 9. So this will give us 3 over 9, which is equal to 1 over 3. And the same thing goes for all of them. So let's try to see if this works. So it means that I have 3% chance of selecting a blue item. So I'm going to select now, and then we check what item it is. I'm closing my eyes. So what's the probability that this is blue? It's 1 over 3. So Basically, the probability is not too much. It's not even up to 50%, but it worked. We selected a blue item. So the two things you want to know is the probability is represented as P, and the item that you select or the event is represented as an item in brackets. Alright? So now let's now go to formally discuss probability by following the procedure we have there. We'll come back to this when we go further a little when we discuss conditional probabilities. So let's see. Assuming you will have a red box containing 2 apples and 6 oranges, as you can see. If you take a fruit from one box randomly, what is the probability that it is an apple? The probability that it is an apple is what is the probability that it is an apple? Then it's going to be number of apples divided by total number of items in the box. So we should have probability that it is an apple is going to be 6 over 8, right? Which is equal to 1 over 6 over 8, which is equal to 3 over 4. Yeah. So probability that it is an orange is going to be what? Is going to also be 2 over 8. So 2 over 8 is going to be 1 over 4. So probability that it's an apple is not total number of apples divided by total number of items in the box. Now this is simple probability. The key thing we are trying to figure out is how to represent probability using notations. Now let's go down a little. Assuming you pick a blue box containing 5 apples and 1 orange, containing, is it 5 apples and 1 orange? So containing 3 apples and 1 orange. If you randomly pick a fruit from this box, what is the probability that it is an apple and probability that it is an orange? Again, you say the number of items divided by the total number of fruits in the box. Alright, let's now go a little further. What if we select a fruit from the red box and the fruit is an orange? Then we select another fruit from the red box without putting back the first one. So we are actually selecting for the first time. We are not replacing it, and we are selecting a second time. What is the probability that the second fruit is an apple? So this is where we now have to think of what to do. Consider that the first fruit was an orange. It then means that the total number of fruits is now 7. Okay, so let me write. So basically what we are saying is that we are asking what is the probability that the first fruit, the second fruit is an apple. So we are saying that when you select for the first time, if it's an orange, the total number of oranges reduces to the total number of apples reduces to 5, and then the total number of fruit reduces to 7, and therefore the probability that the second fruit is an apple is 6 over 7, because we now have 6 apples divided by the total number of fruits, which is 7. And the same thing goes for the orange. What is the probability that the second fruit is an orange? If the first one is an orange, then it means that the total number of fruit left is now 7, and it means that only 1 orange is left. And so the probability that the second fruit is an orange will be 1 over 7. In these two cases, since we are giving prior condition, we call it conditional probability that we are going to discuss later. So what we are saying is that consider that the first fruit was an orange, then what is the probability that the second one is an apple? In the second case, we have, assuming that the first fruit is an apple, what is the probability that the second one is an orange? So this is a little bit confusing, but I assure you it is very, very clear if you take your time to go through. Alright, so this is basically probability that we learned from high school. We are not going to spend time talking about this. Let's now discuss what is called experiments and random variable. So in probability theory, you always will hear about experiments. What is an experiment? Experiment in machine learning is not about experiments in the lab or in the chemistry or biology lab where you have to do titration and things like that. In machine learning, when we're talking about experiment, we are talking about events that happen randomly. This is the same as used in statistics. This means that we carry out certain procedure and at the end we reach certain conclusion and make inference. For these procedures, the outcome is actually random. Okay. For instance, when we have the box of orange and apple and we are picking something from there, then it's an experiment we are carrying out. We are trying to know what the outcome will be. Or if I have this box of papers here and I decide to pick one item from here, what is the probability that this item I pick is pink or blue? So that is called an experiment because the outcome is actually random. Alright, so let's take a simple example now. Okay, we are talking about a random variable. A random variable is a variable that can take on random values. So say it several times, a random variable is a variable that can take on random values. In this experiment, we put the two boxes side by side, then we randomly choose one box, and then we randomly select a fruit from one of the boxes, and we record what fruit it is. Okay? Now, think of this experiment in this way. I'm going to scroll down. In this experiment, we are putting the two boxes side by side. Step 1, we select a fruit from the box and we place it beside. Right? We select a fruit from the box. We select first a box randomly. We choose one box, either a red or a blue box. And then from this box, we select a fruit from this box. And we repeat this process several times, let's say 100 times. And we are recording the figures we have. So for 60% of the time, we selected the blue box, and for 40% of the time, we selected the red box. So in this case, we have probability of selecting the blue box is 6/10, while the probability of selecting the red box is 4/10. How does this have to do with random variable? Okay, now let B be a random variable, and random variables have to take on values. A random variable is a variable whose values are the output of a random experiment. So if we are saying that B is a random variable, it means that the value that B could take will be the outcome of a random experiment. B can randomly have two possible values, either it's a red box or a blue box. If this is the case, it means that B is a random variable because it can take on two values. Those two values will be either a red box or a blue box. Also, F can be a random variable that represents the fruit. F can either take on two values, either it's an apple or an orange. So in this case, we are now ready to use some notations to represent random variables and probabilities. And this is the important part I want you to pay attention to. So we have that. Let's try the outcome of the experiment using probability notation. Based on the experiment, the probability of selecting a blue box is 6/10. So what we can write, the probability of selecting a blue box, so let's say probability of selecting a blue box. So we are saying that B is a random variable that represents the box, and now it can take on value of B, which is blue, right? And probability that this random variable B takes on a value of blue, or let me just write it out in full so that it will not be confusing. So probability that B takes on blue is equal to 6/10, and the probability that this box is a red box or takes on the value red is equal to 4/10. This we recorded from the experiment we carried out. Remember, we mentioned that we did the experiment 100 times, and for 60% of the time, we're always selecting the blue box. Okay, so this we've written down can be shortened in this way. So we can shorten this is the same as P blue is equal to 6/10, and this is the same as P of red is equal to 4/10. So what I want you to remember from here is, in case of random variables, they can take on two different possible values that are the output of a random experiment or the outcome of a random experiment. And now we can actually replace this equality inside the probability notation using the values of this random variable. In the same way, we can also represent it in case of the fruits, because these two we mentioned are just for the box. So if I scroll down, we have, suppose you select a fruit from the blue box, then we replace it and select again from the same box, blue box. What is the probability that the fruit is an apple? But before I allow you to do these exercises, I would like you to represent the probabilities of the random variable that represents the fruit. I want you to represent it in probability notation. So in this way, I've done in this case. Then also take some time to do these exercises I've left here. Try to use the experiment of the box of orange and apples and solve these problems here. And also B, say solve the same 4 probabilities this time. Suppose the first fruit was not replaced before the second selection. So I hope you understand it. If not, try to go back, read through. Everything is well specified and clear in this place, and also try to understand the concept of random variable and also the concept of experiment in machine learning probabilities precisely. And one more thing I'd like to tell you is that always try to do the quiz, because doing this quiz will help you make the concept very, very clearer to you. I'd like to remind you to subscribe if you've not subscribed, and also share it around, and also leave a comment to let me know if there's something I need to do better.